Hey everyone, it's Mr. Canfield. Sorry this is not an acrylic pour video. I will get back to revamping my channel and turning it into an acrylic pour channel later, but we have math to do. So this is Algebra 1, Chapter 7-2, multiplying polynomials. I have my mask on my chin. Why? No one's in the room with me. All right, so multiplying polynomials. All right. So last time we looked at like adding and subtracting, we looked at the names. Now we're looking at multiplying. It's in the name. Why am I telling you all this? Okay, so our first example, it's got a bunch of different examples. We're gonna talk through all of them, and then the assignment is some practice. So the book starts us out with this problem, but it doesn't write it like this. It says, what's the product of negative 4x cubed and this? Product means times. I don't know why we're starting with it. Anyway, so here we go. All you've got to do when we're multiplying is two things. As we distribute, so we're going like bop, 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 right? Because this times everything. We're going to be multiplying coefficients. Oh yeah, and there's a coefficient here, right? It's hiding. It's a 1. So remember, if you're forgetting that, feel free to put that 1 in there. It's a good little reminder. We're multiplying negative 4 times each of these numbers. So like negative 4 times 1 is negative 4. Negative 4 times positive 3 is negative 12. And negative 4 times negative 4 is positive 16. So the first thing we do is we multiply coefficients. And the second thing we do is we're multiplying x cubed by x squared, but remember that to multiply two different things that have the same base and different exponents, we add the exponents. So this is going to be 3 plus 2, that's x to the 5. This is going to be 3, there isn't an exponent, oh yeah, no, it's a 1, right? 3 plus 1, x to the 4. 3 plus, there's no x here, so this is x to the 3. And that's how we multiply polynomials. So we use the distributive property, and then we multiply coefficients and we add exponents. It's that. That's not the entire lesson, but that's a really, really good chunk of it. So here's our second example. This time, we've got a 2x squared outside of x squared plus 3x plus 4. And so if I'm doing this one, it's so stinking similar to the last one. But we take this guy, and we're gonna be multiplying it by all three of those. We're distributing it to each of the terms. And so let's see, 2 times 1, so I get 2. And then I have x squared and x squared, so I add those and I get x to the 4th. So that's I'm normally gonna do it all at one term at a time. So 2 times 3 is 6, so plus 6, and then x squared and x, it's 2, and that's 1, so 2 plus 1 is 3. And then x squared and 4, oh wait, sorry, 2 times 4 is 8. And there's no x on this, so we just get the x's from that one. Okay, so there's more complexity that you can bring in with more letters, more terms, but this is the general idea, and I really want to focus on stuff that we're going to see more often. All right, so time for example 3. And example 3 says this, 2x plus 1 times x plus 3. So if you've taken Algebra 1 before, you've seen these a billion times. If you haven't, welcome. So now instead of having some monomial being distributed, we have a binomial being distributed. There's a ton of ways to do this. I'm going to show you my favorite ways, but there's more. And if these ways don't work for you, we can try other ways. Key thing is to find something you're comfortable with and practice that. So And just real quick, I just need to mention this. The reason that we are doing this is not just so you can take these and multiply them out and rewrite them and stuff like that. We're learning the alphabet of math. We're learning basic ways of speaking and moving in math to get from one thing to another. So I haven't done any solving today. All I've done is said this and this, they're actually the same thing, they're just written different ways. So this line and this line, there's no difference other than how they appear. This and this. If I was to plug something in for x here or plug it in here, I get the same number. Just like in number 2, if I plug something in at the beginning or I plugged it in at the end, I get the same number. So we're just looking at something in a simpler form. So like right now we have this, which might feel simpler than the answer. It's just in math we say that it's simpler when there's no more operations to do. So that's all that's happening. Okay, enough of an aside. So one way that we do this is we use the distributive property and we just double distribute. So like I'll start with my 2x and I'll go 2x times x and then I'll do 2x times 3. Notice I'm not doing the 2x times the 1 because that's in this parentheses. It's not in the one that we're being multiplied by. So let's see, 2x times x, that's 2 because it's a 2 and a 1, and x squared because it's an x and an x. Then 2x and 3 is plus 6x. And then now that I've taken that 2x times everything in the other parentheses, I can take the 1 and do the same thing, times everything in the other parentheses. So that's 1 times 1x is plus 1x, and then 1 times 3 is 3, and there's no x's at all. And so if we look at that, oh, I have a like terms, right? I have plus 6 and plus 1x, so I can combine those. 6x and 1x is 7x, as we talked about last time. So now we have our 2x squared plus 7x plus 3, and that's that. Okay, so just another reminder, all 3 of these lines, if I plug something in for x, I get the same thing on all 3 of the lines. This is just considered the simplified form. This is something that we're going to call factored form. We'll get more into that later. So this is one way to do this problem. And this is my preferred way to do this problem, my personal way that I prefer to do it. Everyone's a little bit different. Here's another way. I call this way the box way. I did not make this up. Our book actually teaches this. And the box way looks like this. So you take your 2x plus 1, and you can either write it along the side of your box or along the top of your box. I'm going to write it on the top of the box. And so I have 2x and I have plus 1. And what I'm going to do is this is the top of my box. And I'm going to draw a line down. And then on the side of my box, I'm going to write my 1x and my plus 3. And so now we've made this box. And in each of these 4 pieces of this box, I've got a little rectangle, right? And this rectangle has a side of 1x and a side of 2x. Well, how do we find the area of a rectangle? Well, through multiplication, right? So we do 2 times 1, and we get 2, and x times x, we get x squared. So the area of this little box is going to be 2x squared. Then I'm going to go over here. Well, this side is, let's see, this side is 1x, right? This side up here is plus 1. So we're going to do x times 1, or 1x times 1, and we get plus 1x. Some people don't write the pluses in here, and some people also don't write the 1x's, but they just write, this would just say x for a lot of people, and that's totally fine. Down here, 2x plus 3, that's plus 6x, and then down here, plus 1 plus 3. 3 times 1 is 3, okay. And then I'm going to combine my like terms. Let's see, so x squared is not a like term because it's got the squared, and those don't have squareds, but I do see that these two diagonally across from each other, let's see, plus 6x, oh, that's 7x, okay. Then I have my 2x squared, it's just going to come down, and I have my 3 going to, oh wait, I don't have any signs in here. They're all positive, right? So I'm going to put pluses. And there we go, same answer. Same answer and basically the same amount of space. I don't care which way you do. but these are the two favorite methods that I know. And if you like to go fast, the fastest way that I know is this way, especially when you can do things like this and say, okay, and this is the last time I'm doing this example, I promise. If you're going to do this truly fast, you'd go, well, 2x times x, that's 2x squared. And then I see my 1 times x is 1x, and I see 2 times 3, that's 6x. 6 plus 1 is 7, and then 3 times 1 is 3. This is the third and final way. This is not recommended, but I know that some of you like to do things in your head. It's an option. Okay, so let's move on. I think I can fit this into one piece of paper. We're just gonna we'll do one more example each way, and then we'll look at one final example. So now let's say we have 5x minus 4 times 2x plus 1. So I'll do this one. We call this the more traditional way, that this double distributing. So 5x times 2x. Let's see, 5 times 2 is 10. X times x is x squared. Then 5 times 1 is 5, and the x comes with it. There's no x on that one. Then, so instead of going above, you can also go underneath, like that. And remember this, since it says minus 4, we actually want to think about this as a negative 4 when we multiply. So negative 4 times 2 is negative 8. So I'm going to write minus 8, and that's got an x. So minus 8x. And then minus 4 times plus 1 is negative 4, so we'll write minus 4. And then we'll just combine our like terms. They're not always going to be in the middle, but they're very often going to be in the middle. So 5x minus 8x, that's negative 3. X minus 4 comes down, the 10x squared comes down, and we're done. And then I'm going to do one the box way. And again, I don't care which way you do. So whatever works for you, like do that way. If you want to do box way for every single one, great. If you want to do the excuse me for every single one, that's fine too. If you want to do the double distribute, by the way, this is called foiling. You'll hear foiling a lot. I don't use the acronym FOIL, and I think that it's a dangerous acronym, so I don't teach it. But if you have any questions about FOIL, I can show you. It's just, it only works in certain situations. Oh no, I just drank coffee. Hopefully the slurp was not awful. Okay, sorry. So let's do a box for this. So I'll do 3x and minus 5 along the top, and then I'll do 2x and plus 4 along the side. So another way that people do it, instead of doing it like this, they'll just draw, and they'll just kind of leave it like that. Totally fine if you want to do this. Everyone's a little bit different. There's lots of cool visual organizational strategies we have for this. Anyway, 2x, 3x, 2 times 3 is 6, xx is x squared. 2 times negative 5 is negative 10, and then there's a single x. 3x times 4, 3 times 4 is 12. And there's a single x. And then negative 5 times negative 4 is negative 20. So in the box method, a lot of times the diagonals are going to be like terms. It's not guaranteed. It does happen a lot though. So don't be surprised if your diagonals are going to be your like terms. So I got a positive 12, I got a negative 10, that's a positive 2. So plus 2x, my 6x squared comes down, my minus 20 comes down. Oh, I didn't talk about this in my last set of videos. This is called standard form, the way I've been writing these. You might notice I always start with the x squared. I'm always starting with the highest exponent, and we decrease down from that. And it's just it's a clean way that we organize things. 6x squared plus 2x minus 20 is the same as negative 20 plus 6x squared plus 2x. Those are the same thing. This is just organized. We might say it's like an ABC order kind of thing, right? Alphabetical order, but in math, it's not alphabetical, it's, we could say descending by power. I wouldn't mark this wrong. This is just the standard way that you see it. Okay, I was wrong. I can't fit this on one piece of paper. Sorry, but you know, I just turn over to the back. The reason I don't turn over to the back is because I write with marker, so it comes through the page. All right, so the last level that we reach is, well, okay. To be fair, there is no last level. You can always make these bigger and more complicated. But if you remember, we went from one piece times a bunch of things to two pieces times each other. We could do two pieces times three pieces. And so the cool thing about the process that we've learned, either the box or the double distribute, is it works the same no matter how big the pieces are. The double distribute way, you would take your 2x, oop, I start with the wrong color. Consistency, Canfield, come on. So 2x, we take the 2x, just times all three of them. And we're gonna go through, we're gonna do that. Then we're gonna take the minus 5 times all three of them. Let's just say, for the sake of argument, you had three things and three things. You would do this idea, do the first one times all three, second one times all three, third one times all three. Like, it's obnoxious, takes a while, but that's all you gotta do. So if I'm doing this method, and I don't recommend drawing all the lines all at once because you can get lost pretty easily, but I already did it, so. 2x times negative 3x squared, well, that's gonna be negative 6, and x squared is x cubed. Then 2x and plus 4, that's plus 8x. Nope, x squared, right? Remember, that's x to the 1. Then 2x times minus 7 is minus 14x. Then I go in with my red, and let's see, negative 5 times negative 3. Ooh, negative times a negative is a positive, so plus 15. No x is x squared, so x squared. Negative 5 times 4 is negative 20. And there's an x. I say 20, I don't say 20. I just was trying it out. Negative 5 times negative 7 is plus 35. Side note, on our next quiz, tell me what your favorite number is at the top of your favorite number to say. Random question. And if you do that, I might throw some bonus points your way. That's the secret hidden question for those of you that watched the video and who paid attention. So your favorite number to say. And it can be fake numbers too. Like my favorite fake number is a bajillion. I'd probably say that one the most. So yeah, whatever. What's your favorite number, fake or real, to say? All right, let's finish this up. So I'm not going to put any hints on the quiz about it whatsoever. So you have to remember. But hey, if you take good notes or you put a note somewhere, don't tell other people. This is between you and me. If everyone does it, might not give everyone extra credit. I don't know, because I know not everyone watches these videos. All right, so let's find out like terms. We got negative 6x cubed, then I see plus x squared. Here's another x squared, so 8 plus 15 is 23. And then minus 14x minus 20. Oh, those are both negatives, okay. So that's negative 34. And then 35 doesn't have any friends, okay. So that is one way to do these longer ones. I'm gonna do the same problem, but in the box way. So you can do the box way either way. You can put the 2x minus 5 along the top like we've been doing. You can put it down the side like we've been doing. It doesn't matter. So I like my boxes to go longer this way and shorter this way. That's my personal preference. So I'm gonna write the 2x and the minus 5 here, and then my negative 3x squared plus 4x minus 7 along the top. So for me, this is how I want to write the box. If you would rather say 2x minus 5, negative 3x squared plus 4x minus 7. If you prefer this, do this. It doesn't matter. Oops. Well, I guess the lines kind of do it for me, but it doesn't matter. Either way is good. And it's going to work out the same way. We're going to get the same answer, just a different way to approach it. So 2 times negative 3 is negative 6. X squared is x cubed. Then 2x, 4x, 2 times 4 is 8. X squared. 2 times negative 7 is negative 14. There's an x because there's one of them. Negative 3x squared, negative 5 is positive 15x squared. Negative 5, positive 4 is negative 20. Again, that's how I actually say that word. Negative 5 times negative 7 is positive 35. Oh, wait, I didn't write pluses elsewhere. Okay. So, cool thing about the box method is usually like terms show up diagonally. It is not guaranteed though, so don't take that as like, oh, every time this happens. So let's see, I got my negative 6x cubed, and I'm writing this in standard form. I'm writing my biggest exponent first, my second biggest next. So plus 23x squared. Negative 20 and negative 14 is negative 34 when we add those, plus 35. Okay, final reminders. Calculators, use calculators. For negative 20 plus negative 14, you can do negative 20 plus negative 14. You don't need to figure these things out in your head. If you can, great, I'm happy for you. Like it saves you time. But if you need the calculator, just recognize your need for it and use it. All right, so sorry this was a little bit of a longer video, but I hope that was helpful, and now you should be able to do the practice. So, yep, that's it, bye.